Hello, I'm here to give you an introduction to a new pressure sensor Danfoss Sensing Solutions is launching. This is a pressure sensor that has a communication module embedded. The name of the sensor is DST P10B. The pressure sensor it has been built on is the well-known DST P140, which is a pressure sensor tailored for various industrial applications. And the communication module I'm here to talk about today is a CAN bus, and more specific, a CANopen protocol embedded in the sensor. To illustrate this, I will use a little equipment here, as you can see. So a power supply to power up the sensor to the needed voltage level, of course. I have a communication tool here, which in this case is from Peak. But this could basically be any CANopen communication tool available on the market. The tool itself is connected to the sensor and then via a USB interface to my computer, where I have a software where I can modulate and configure the sensor. Before I connect my sensor to the communication tool, I would like to give you a little introduction to the protocol we have embedded. First of all, the sensor is fully compliant to the CIA organization, so this means CAN in automation. And the protocol this has been built on is the CIA DS301. The profile itself for a device like this is the DS404, which is the profile for measuring devices and closed-loop controllers. Another important feature we have decided to embed is the LSS function. So this means the layer setting service function, where you can use your controller interface to program several settings at once. The other important communication to the sensor, of course, will be via the PDO, so the process data object side, or the SDO, which is the service data object side. Here we have one PDO embedded in the sensor, which can handle the data flow to your application. From a support and service point of view, this sensor will be delivered with an EDS, so an electronic data sheet, that you can use to make the implementation on your side easier. As already mentioned, the sensor is compatible with basically any CANopen tool available on the market today. So whatever fits to your needs or what you already have available, you can use also for the communication with this device. Now let's take a closer look on some of the features we have decided to embed in the sensor. Features that are important for you if you want to have communication with the sensor and to configure it for your application. So I will go and touch base on several topics here. I will show you how to set the baud rate, how to set the node ID. I will give you a little introduction to the PDO mapping and your choices on that side. And I will give you an overview of how the PDO transmission can be set up as well. Then there is a different topic, which is setting the filter, because we have embedded filters in this as well. We have decided to embed two types of filters here. And then, as you can see, we also have CAN emergency, also fully supported here, of course, and some diagnostics features that will link specifically to the sensor itself. Then the sensor supports heartbeat and node guarding as well, as standard CANopen features. I will now connect the sensor to my setup here to demonstrate some of the features and functions we just discussed. I will then power up the sensor here with my power supply here. And the sensor itself has to be supplied with between 9 or 36 voltage. So I have put mine to 24 here and will turn the output on now. So this means I basically start to have the communication now via the Peak CAN tool. This communication interface or device explorer actually takes all the different objects we have embedded in the sensor and divides them into 3 segments. One which is called a communication segment, one which is called manufacturing segment, and one which is called device profile segment. So this is where you will find all the different functions and features you can access and use to configure or get information from the sensor.